All right, so a little bit of an interesting question here to ponder. How can we know that something in math is true? All right, so I just want you to think about that for a little bit. And now, so looking at a specific statement, I'm going to see, can we know if this is always, sometimes, or never true? All right, so something we could do here, just to get an idea of what's going on, is we could look at a specific example. So let's say if we let m equal 5. All right, and then 5 plus 1 there, that's 1/6. So we want to go ahead and check to see if that's the same thing as the right-hand side. So let's actually just start by simplifying this. So if I want to do this, I need to go ahead and have a common denominator so we can subtract these fractions. So here I could see, 5 times 6 will give me a common denominator. So we can multiply the first fraction by 6/6. And the second one by 5/5. All right, and that'll give me 6/30 minus 5/30 is 1/30. If I go ahead and do the same thing with the right-hand side here now, it's 1/5 squared plus 5. It's 1/30. All right, so I just picked 5 randomly, by the way, so you could pick any number you want. But this shows me that this statement here, up at the top, that this is true for the specific case where m equals 5. Now, really, that doesn't tell me a whole lot. Because does this tell me that this is always true? Well, so far we know it's sometimes true, but for all we know, there could be some number out there where this doesn't work. And at this point, we only know it works for one example. So if we want to see if this could always be true, what we'll want to do instead is start with the left-hand side of this equation and see if we can make it look like the right-hand side, just using algebra. So let's go ahead and do that. Okay, so we'll start off actually pretty much the same as what we did here. We need a common denominator. So something I can do here is multiply the first fraction by m plus 1 over m plus 1. And the second fraction by m over m. Alright, so let's go ahead and simplify that. So with this first fraction, that becomes m plus 1 over m times m plus 1. The second fraction is m over same thing. Okay, so now we can subtract the fractions because we have common denominators. So here, this m plus 1 minus m, that'll give me 1. And in the denominator, if I distribute, that is m squared plus m, which is what we had for the right-hand side of the expression. All right, so doing this generally, now we can show that our original algebra statement up here, we can show that that is always true. All right, so sometimes we might need to specify, what type of number that we're working with. Here I didn't do that. But for something like this next one, where we're talking about odd numbers and even numbers, I really need to know what kind of number I'm working with, right? Because if I start having irrational numbers or something else, this really wouldn't make a whole lot of sense. So if we're talking about odd and even numbers, those need to be integers. And let me just talk about what these are real quick. So these are different types of numbers that we have. Some of these, the symbol that goes with it is, not too hard to remember. Like for real numbers, we use a R. The ones that are a little bit strange are like rational numbers. We use a Q. So you could actually remember that for the Q, quotient, because rational numbers can be written as fractions. They can be written as quotients. Integers, I don't know why we use a Z. There's probably a reason. If you find out, let me know. And when we're looking at irrational numbers, that's the set of real numbers that aren't rational. So here can use a Q with a little c up here, so that's Q complement. This down here is an alternate way of writing that. Okay, so enough about that. Here, I said with even and odd numbers, we're looking at integers. So we need to go ahead and find a way to define what our odd and even numbers are. So with even numbers, we're looking at numbers that we can divide by 2. Right, so for example, if I had 2 times n, as long as n is an integer, I know that this gives me an even number. So I can plug in any integer for n, it's going to be an even number. And you can actually check to see that this gives you all of the even numbers. Alright, so now how do I make sure that I get an odd number? Well, if I go ahead and add 1 to that, it's going to be odd. Something else I could do here is I could also subtract 1 from that, and it would also give me all the odd numbers. Okay. So now in my statement, I'm looking for the sum of 2 odd numbers. All right, these could be different odd numbers, so let's use a different letter. So go ahead and use M. All right, and let's say where M and N are integers. All right, so the way I wrote this, it shows M and N are elements of the set of integers. Okay, so to see if this will always give me, if the sum of these two things will always give me an even number, what I have to do then is we'll add them together. And so let's rearrange this a little bit. Maybe 2n plus 2m plus 2. And then now I can see I can factor out a 2 from everything. And there we have it. So I can see here n plus m plus 1, those are all integers. So that whole thing there will come out to an integer, and then we're multiplying it by 2. Since I have some integer multiplied by 2, I know that this will be an even number. So I can see here I started with 2 odd numbers, added them together, and I end up with an even number. So now we know that this is a statement that is always true.